Hello, and welcome back to this quiet space we share. Tonight, the moon outside is just a soft curve, and the dark feels deep enough to hold all our questions. Wherever you are, allow the edges of your room to gently blur and your mind to settle, like dust falling slowly onto a still lake. We are letting the world's hurry fall away, inviting only wonder in. We're going to whisper about something that feels both immensely vast and impossibly quick. A silent, constant truth woven into the fabric of the universe. Have you ever stood in the dark and felt the sheer patience of the stars? That light you see left its home perhaps years ago, traveling without pause, at a speed we can barely grasp. Tonight, we'll turn our thoughts to this ultimate velocity, exploring what it really means to move through space and time. We'll gently ponder the beautiful, unbreachable barrier of the cosmos, wondering what happens when we reach for the one thing that can never be caught. If these quiet ponderings bring you a little peace or help your mind unwind, a gentle like and a soft subscribe helps others find their way to this calm, too. Only when it feels true to you. For now, let your thoughts grow light, your curiosity become a gentle guide, and we'll begin this unhurried journey together. The beginning is dark, but not the kind of dark you know. Not night, not the shadow behind a door, not the soft dimness after a lamp is switched off. This is a deeper quiet, a darkness that has never been interrupted, because nothing exists yet that could shine. No stars, no galaxies, no eyes, no surfaces for light to touch. Only a dense, hidden sea of energy, hot, beyond imagination, holding every future in a form too small to picture. You float in that first moment, as if in the pause before music begins. The universe is a tiny, trembling point, smaller than any dust you've brushed from your sleeve. Inside it, space and time and all possible stories are folded together, silent and waiting. It isn't black, because black needs something brighter beside it. It isn't really dark at all, because there is nothing to compare. It is simply potential, held like a breath. Then the breath is released. In a fraction of a second, that point swells. Space stretches faster than any thought. Temperatures soar, then begin to ease. Energy turns into particles that flicker into existence, collide, break apart, recombine. It is chaos and creation at once, an ocean of movement with no shore. And still, there is no light in the way your eyes would recognize. Nothing like a star, nothing like a flame. The young universe is so hot and so crowded that light has no freedom. Photons, those tiny packets of light, are born everywhere, but they cannot take a clean path. Every step, they are scattered, turned, absorbed, created again. They bounce in every direction, imprisoned in a storm of charged particles. Like thoughts that can't escape a busy mind, you drift in this glowing fog, where every direction looks exactly the same. No up, no down, no here, no there. Just a uniform, seething brightness trapped in place. Yet light is already present in this confusion, even if nothing can yet see it. As the universe expands, its fierce heat gently softens. With each heartbeat of cosmic time, space grows and the chaos cools, like breath fading from a cold window. What your imagination feels as ages passes on a much larger clock. About 380,000 years after that first expansion, still only the blink of an eye, by cosmic standards, something delicate happens. The fog begins to thin. The universe has cooled enough that wild, free electrons start to settle, joining with nuclei to form the first stable atoms. The storm calms. The particles that once trapped photons in endless collisions now bind together, leaving more open space in between. The cage unlocks, and light slips free. This quiet turning point is called recombination, but you can think of it as the first true breath of light. Photons that were once trapped now begin to travel in straight paths, moving outward in all directions, starting journeys that could last for billions of years. Some are swallowed quickly, others wander on. A surprising number of them are still moving now, passing silently through the room you're in, through your body, through the space between your thoughts. Over time, as the universe has stretched, their fierce glow has cooled into a gentle, invisible murmur. Scientists call this the cosmic microwave background, the afterglow of the first light that could finally move freely. If you pointed a sensitive antenna at the sky, the faint hiss you'd hear, hidden behind human noise, would be that ancient light, still humming softly like a lullaby that has never quite stopped. You can imagine lying back within that glow, floating on waves too long for your eyes to see, cradled in the memory of the universe's first clear exhale. In that calm, the question rises, what is light, really? It isn't just brightness on a wall or a glint on a glass. Light can behave like a particle, a tiny packet you could count, and like a wave, a smooth vibration spread out in space. It has no rest mass, no weight you can place on a scale, yet it carries energy and momentum and can warm, push, and change the things it touches. Light doesn't need air or water or any substance to travel through. It crosses the vacuum between stars without a path or a track, weaving through emptiness as if emptiness were enough. It can bend around massive objects, slow down inside glass or water, scatter in fog, and break into colors in a prism. It paints sunsets and rainbows, reveals galaxies, and quietly carries information. Every photon that reaches your eyes is a tiny messenger, telling you something about where it came from. It's how you see, it's how you know, it's how these words reach you now. Light also plays a strange game with time. Once a photon is created, it travels at one speed, what we call the speed of light. Always the same, always the fastest, anything can move. It never slows down, never rests. A photon that has been traveling for 10 billion years is, in an important sense, just as it was the instant it began. It doesn't wrinkle or fade with age the way you do. You might wonder what that feels like, if feeling even applies, to exist without time passing in the familiar way. No long afternoons, no waiting rooms, no countdowns. No before to remember or after to anticipate. Just a continuous now of motion, always at the same pace, never stopping, never arriving late. Every morning when sunlight spills softly across your pillow, it's part of this same story. Each beam that touches your skin is a distant descendant of that first liberation of light, that ancient moment when photons were finally allowed to roam. The glow that warms your face belongs to a family that began when the universe took its first clear breath. You are shaped by this light in ways that are both obvious and hidden. The atoms in your bones were forged in stars that shone by releasing light and heat. When those stars died, they spread their elements, seeding future clouds, planets, and bodies like yours. The food you eat exists because plants learned to drink sunlight, turning photons into sugar, leaves, and fruit. Your days and nights, your sleep and wakefulness, your moods and dreams all sway gently to the rhythm of light and dark. You don't just observe light from a distance. You are, quietly, made and guided by it. And yet, for all that closeness, light remains strangely out of reach. It feels immediate. You flip a switch and a room answers, but when you try to hold it in your mind, it keeps slipping away. It is wave and particle. It moves through emptiness, yet carries so much. It obeys simple rules that twist your intuition into new shapes. That is where a gentle curiosity arises. One that once visited a young patent clerk named Albert Einstein as he stared out of a window and let his thoughts wander. What happens if you try to catch light? Not just follow it with your eyes the way you watch a sunbeam crawl across the floor, but truly chase it. What would it mean to run beside a photon, to move so fast that time itself starts to bend around you? You might imagine that you're lying very still now, but in your mind, you begin to move. Not with rushing footsteps or roaring engines, but with a quiet, focused wondering. Somewhere in your thoughts, a single photon is born, perhaps from the surface of the sun, perhaps from a distant star. It rushes outward at its constant speed, the universal speed limit. You decide, softly, to go after it. At first, you are slow. In this inner world, you picture yourself walking, then jogging, then running. The photon does not react. It doesn't know it's being chased and wouldn't care if it did. It simply continues at its own pace, always the same. You imagine some unseen hand turning a dial, letting your speed rise higher and higher. In ordinary life, more speed means more success in catching something. Throw a ball and sprint after it. With enough effort, you can reach it. Race a car. With enough power, you can overtake it. But your chase after light feels different. No matter how much you imagine accelerating, the photon always stays out ahead. From your point of view, it moves away at the same speed. From a friend watching from far behind, it moves at that same speed as well. Light refuses to behave like a normal, catchable thing. As your imagined speed grows, something else begins to change, not in the photon, but in your own experience of the world. Time, which usually feels like a steady background rhythm, starts to soften and stretch. At first, the effect is delicate, almost easy to overlook. Your inner sense of seconds feels slightly wider, as if more can fit into each one. A clock you carry in this imagined ship seems to tick more slowly compared to all the distant clocks you left behind. This isn't an illusion. It's a real feature of the universe, called time dilation. From your own perspective, everything about you still feels normal. Your heartbeat, your thoughts, your pulse of moments all seem right to you. But if someone could watch you from a calmer frame of reference, they would see your time flowing more slowly than theirs. Your days could pass while their years go by. Space joins this gentle distortion. The distance in front of you shrinks, like a long road appearing shorter as you speed down it. The universe in the direction you're going seems squeezed. This is length contraction, another quiet piece of how reality works at high speeds. Space, like time, is not rigid. It responds to motion, flexing and folding in ways that are hard to picture but deeply real. Through all of this, the photon never changes its pace. It does not speed up to escape you. It simply continues at its own unchanging speed from every perspective, always. If you imagine riding a ship close to that speed, your onboard clock might show only a few days passing, while decades slip by on Earth. The stars ahead would seem to crowd together, their colors shifting. Light from behind would stretch toward red. Light from ahead would slide toward blue. The sky would no longer look like a calm dome of distant points, but like a tunnel of light, pulled together by your motion. And still, the photon you chose at the start would remain forever just ahead, never letting you share its exact pace. For a moment, let your thoughts try something impossible. Imagine you do catch up, that you somehow become like a photon yourself. If you were pure light instead of matter, what would you experience? From light's point of view, if such a thing can be said, time would not pass at all. The instant a photon is born and the instant it is absorbed would, in a deep and strange way, be the same moment. No waiting, no aging, no journey in the way you understand journeys. Just a connection drawn across space between two events. Your mind struggles with this because it is built to live inside time. You feel yourself changing and aging. You remember yesterday and hope for tomorrow. Your whole sense of self is tied to time flowing. Light slips free of that river. It moves, but not as you do. This gentle chase, this soft sprint beside a photon in your imagination, reveals something profound in a very quiet way. You are not only made of matter sitting in space, you are woven into the rhythm of light and time. Every moment you live, light touches you, shapes what you see, sets your internal clocks. Your reality depends on it, but you can never fully become it without giving up the rules that make you you. To truly catch light, you would have to let go of mass, of ordinary time, of the distances that anchor your life. You would have to step outside the very things that hold your memories, your relationships, your story. So maybe the point is not to win the race at all. Maybe the beauty lies in the chase itself, in letting light show you how time can stretch and space can bend, how something can be both familiar and deeply strange. You don't need to become a photon to be changed by what it has to teach. It's enough to stay as you are, to watch, to wonder, and to let its constant, ageless speed whisper to you about a universe far softer and more mysterious than it first appears. With that thought, you drift gently back from your impossible sprint beside the photon. The rushing stars fade, the tunnel of light dissolves, and you're here again with the pull of gravity and the quiet around you. You never caught the light, but you traced its path in your mind, and that was enough to brush the edge of something deeper, a question that lingers like a low note after the music has stopped. Why is the speed of light always the same? No matter how hard you chase it, no matter how fast you imagine yourself moving, light never adjusts its pace to match you. It doesn't lean forward to help, and it doesn't fall behind. It moves at one precise speed, strange and unshakable. That number is not a suggestion. It is a limit, a rule written into the structure of reality. You rest in that puzzle, then picture yourself again in a still, endless dark. No stars, no planets, only you and a small flashlight in your hand. You click it on. A beam spills out, straight and clean, into the emptiness. Now you begin to move. First you walk, then jog, then run. In your everyday world, you know how speeds add. Throw a ball from a moving train, and the ball's speed is your throw plus the train's motion. Shout while running, and your voice seems to ride the air ahead. So part of you expects light to obey that pattern. Shine the flashlight while standing still, and the beam leaves at the speed of light. Shine it while sprinting, and some quiet, intuitive part of your mind wants to say, now it should go faster, but it doesn't. Whether you stand motionless or race through space in your thoughts, the beam always runs ahead at exactly the same speed. From your point of view, it is that one number. From someone else's, watching you from far away, it is also that one number. It is as if the universe quietly adjusts everything else, time, distance, motion, so this single rule never breaks. That constancy confused people for a long time. In the 19th century, many scientists were sure light needed a medium, something invisible that carried it the way air carries sound and water carries waves. They called it the luminiferous ether and designed careful experiments to detect it, hoping to feel Earth drifting through this hidden ocean. But every test came back empty. No ether. Light seemed to need nothing at all to move. Years later, in a quiet office filled with papers and stamps, a young patent clerk let his imagination wander. Albert Einstein was not famous yet. He simply sat at a desk while his thoughts traveled far beyond the walls around him. One of those thoughts was gentle and radical. What if the speed of light is constant, not because of something light is doing, but because of the way space and time themselves are built? What if they are the things that bend and stretch to keep that number the same for everyone? From that question, a new picture of the universe unfolded. It became the theory we now call special relativity. In this picture, the constancy of light's speed is the anchor, and everything else adjusts around it. When you honor that one rule, odd things begin to appear. Time slows down for fast travelers. Lengths in the direction of motion shrink. Two events that seem simultaneous to one observer may not line up for another who is moving differently. These distortions are not light misbehaving. They are the rest of the universe rearranging itself around light's unchanging stride. Light is the reference, the cosmic speed limit woven into the fabric of space-time. That particular number turns up quietly in many places. It hides in the equations of electricity and magnetism, in the link between energy and mass, even in the signals that help your phone find its place on a map. Satellites orbiting Earth experience time just a little differently than clocks on the ground. Without correcting for that effect, your location would slowly drift far from where you really are. You lie still for a moment, wrapped in this thought. Light is like a message sent by the universe with perfect timing. Every time it travels from star to star, from screen to eye, it carries not just information, but a shared truth. No matter who measures it or how they are moving, this one speed stays the same. It treats every observer with the same quiet fairness. Because of this sameness, the universe can have reliable laws at all. If light speed were different for everyone, equations would crumble from place to place. The behavior of matter near a distant star might not match what we see in laboratories on Earth, but light keeps its pace, and so the rules remain steady across the cosmos. You picture two observers drifting in space. One floats almost still, the other glides past at great speed. Each holds a flashlight. Each clicks it on. They may disagree about how long a second lasts or how large the ship appears, but when they measure the speed of their beams, they quietly agree. The number is the same. Light becomes the thread that ties their perspectives together. Settling into this idea, you may feel a small, surprising comfort. The universe is wide and mysterious, but here is something that does not shift with viewpoint or mood. A constant that refuses to change, even as everything else flows. Beneath that calm, another thought begins to stir. If space and time are willing to bend so that light speed never does, what does that mean for time itself? Maybe time is not the firm, even ticking you once imagined. Maybe it is more like cloth that can stretch and relax, more like a rhythm that can slow for some while moving freely for others. You imagine your body as a kind of clock, not just the watch on your wrist, but your pulse, your breathing, your thoughts, the tiny processes inside every cell. all of them stepping forward in time. Now picture yourself entering a spaceship, not a roaring rocket, but a quiet vessel that hums softly around you. You sit inside as it glides upward, past clouds, past the moon, leaving Earth's tug behind. You travel faster and faster, though still far below the speed of light. Inside, everything feels ordinary. Your heart beats. You blink and stretch. You look out at the deepening dark. But to someone watching from Earth, if they could see the tiny ticks of your clock, they would notice something subtle. It runs a little more slowly than theirs. A second, for you, lasts a bit longer in their eyes. This is time dilation, a real effect, not a trick of broken machines. Precise atomic clocks flown on airplanes return slightly behind identical clocks left on the ground. Satellites in orbit age a little more slowly than we do. Astronauts experience time a touch differently from the people who wait for them at home. At everyday speeds, the difference is tiny. As you approach light's limit, it grows. In the far reaches of imagination, if you could travel very close to the speed of light, you might feel a single year pass while many years unfold back home. A twin who stayed behind would grow older, while you return having lived through far fewer days. Time stretches for one and softens for the other, like warm elastic that can be pulled without breaking. The fabric that physicists call space-time responds to motion. Change how you move, and you change how you move through time. It is not something separate, ticking outside you. It is woven into your path, your speed, your place in the universe. If you think about this too quickly, it can feel unsettling, as if the floor under your feet has turned gently liquid. But if you sit with it softly, there is a deep reassurance in it too. It means every person, every object, every beam of light follows its own stream of time, unique, yet still part of one great river. You, lying here now, are in your own small current. The faint sounds outside your window, the rhythm of your breath, the slow drift of your thoughts, these are reminders that your time is quietly your own, flowing at its own gentle pace, even as other currents move differently all around you. And with that in mind, you find yourself again in the quiet ship of your imagination, drifting through deep space. Outside the window, the stars ahead have changed. They seem to gather closer, their light sharpened and shifted toward blue, more piercing, more intense. Behind you, the stars look softer, redder, spread farther apart, as if the universe is gently stretching in your wake. This subtle change in color is a trace of your motion, a relativistic Doppler shift, a soft fingerprint left on starlight that tells you your little river of time is flowing at its own special speed. What feels stranger, though, is knowing that your body hasn't warned you about any of this. Inside, you feel ordinary. Your heart, your thoughts, your sense of now, all seem normal. Yet your time is not the same as someone else's. In truth, it never truly was. Even in your real, still body, resting by everyday standards, you are already part of many motions. The earth spins beneath you, circling the sun. The sun orbits the center of the galaxy. The galaxy itself drifts through a larger web of structure. You are always moving through space, carried along on currents you cannot feel. And with each motion, your time is already a little unique. Tiny differences, almost impossibly small, but still your own. Let that settle for a moment. You are always living in your own slice of time. Yet time is not selfish. It reaches into everything. It allows causes to become effects, lets friendships unfold, stories blossom, memories anchor, and futures shimmer. Time gives shape to experience, but it is not hard or cruel. it yields. It bends around your path. Every move you make, even a small one, tilts your track through time, if only by a whisper. For you, the dreamer, the quiet thinker, lying here wondering what it means to chase light, this has a gentle implication. As your imagined speed approaches that ultimate limit, your life is stretched not just across distance, but across duration. To you, inside the ship, time feels as steady as ever. To someone watching from far away, you seem to drift through syrup, your moments stretched out, your aging slowed. Both are true. That peaceful coexistence of different truths is part of the quiet poetry of physics. Time is not one strict beat for everyone. It's more like music. Each of us moves with a slightly different tempo, faster or slower, all woven together into a larger, mysterious symphony. The rhythm you hear, your own inner ticking, is shaped by how you move through the universe. You rest in that idea, and another thought unfolds beside it. Time is not the only thing that responds to speed. You find yourself once more floating weightless inside your vessel, wrapped in the knowledge that your minutes and hours are not carved in stone. They unfold with your motion, soft as silk slipping through fingers. As you glide faster and faster through the emptiness, you begin to sense that space itself is not a still, blank canvas either. It bends, it breathes. When your speed becomes great enough, space in front of you starts to feel as though it's quietly drawing inward, like a thread being pulled through cloth. This is the next wonder. For the swift traveler, distances can shrink. Your ship glides without rumble or wind. No sudden lurch, just a steady forward motion. Yet something is changing. To someone far away, the star you're heading toward remains at its proper distance, perhaps many light years off. But from your perspective, hurtling ahead at a fraction of light speed, that distance seems shorter. The space between you and your destination has gently contracted. This effect, called length contraction, is another soft consequence of Einstein's relativity. Just as time dilates for fast motion, space compresses along the direction of travel. You can picture a simple measuring stick, 1 meter long, held out in front of you. In your hands, it feels perfectly normal. But to an observer watching you rush past at near light speed, that same meter would appear shorter, not bent, not broken, just subtly squeezed. It's like folding a paper map. The cities printed on it don't move, but when you fold the sheet, they lie closer together. For the traveler at high speed, the universe folds in a similar way. Distances that once seemed hopelessly far become more approachable within a single lifetime. Not because you've broken the speed of light, but because space and time have quietly rearranged to honor its limit. From Earth, someone might look up and say, "She's taking years to reach that star, and her aging has slowed." From inside your ship, time feels ordinary, and the star seems to hurry toward you across a shorter stretch of space. Two stories, both accurate, both describing the same journey from different seats in the theater of space-time. That is one of relativity's gentlest gifts. Not hard certainty, but harmony between perspectives. Now let your thoughts turn to a much older traveler, a photon. It has no mass. It never rests. For light, if it could possess awareness, there would be no journey at all. No distance, no waiting, no in-between. It is emitted, it is absorbed. And from its own strange frame, those two events are pressed together, like a single touch with no gap between. You are not a photon. You carry mass. You feel time. You stretch across intervals. But as your imagined speed grows, you begin to taste the outer edge of that different way of existing. Space ahead of you seems to soften, to melt and reshape. Distances that once felt like impossible gulfs now appear more like narrow rivers, crossable and calm. Slowly, you begin to understand something beautiful. Space is not a rigid stage that exists out there, waiting for you to step onto it. It is a relationship. It depends on how you move and from where you look. Just like time, space responds to your journey. The faster you go, the more it seems to draw in around you, not as a trap, but as an embrace, adjusting itself so your story can unfold without ever breaking the rule of light speed. This is why explorers and dreamers speak softly of relativistic voyages, not of outrunning light, but of working with the pliable fabric of space and time, letting the universe fold inward as you press forward. In theory, distant worlds could be reached in a lifetime, not by cheating the limit, but by allowing that limit to reshape the path. You rest with that image, stars seeming closer, distances gentler, space itself feeling kind to your motion. The more fully you commit to a path, the shorter it may seem, not because the world shrinks in any absolute sense, but because movement changes what far and near mean to you. Perhaps space is not just background at all, but a partner in a slow, patient dance, always answering the tempo you choose. And within that dance, something larger begins to take shape in your mind, a sense that time's rhythm and space's softness belong to one deeper fabric, holding both together in a single, quiet design. If time can stretch and space can contract, you might quietly wonder what kind of universe allows that. What kind of mind first sensed that space and time don't stand alone, but belong together like threads in a single cloth? To follow that feeling, you drift now not through galaxies, but into the stillness of one thinking mind. A little more than a century ago, a young clerk sat at a desk in a patent office in Bern, Switzerland. The room was ordinary papers stacked, stamps clicking, a window looking out on trams and cobblestones. Clocks on the wall ticked with the same steady rhythm as everywhere else. But inside his mind, that rhythm was starting to loosen. This part of the story belongs to him, Albert. Not yet famous, not yet a face on posters or in textbooks. Just a curious person who couldn't stop turning simple questions over and over. You might feel a quiet kinship with him as you lie here. His story is less about genius and more about wonder, about daring to follow a small thought all the way to its consequences. He began, as you did, with light. He pictured himself chasing a beam across space, running beside it. What would he see if he caught up? If he somehow matched its speed, the wave of light ahead should appear frozen, a standing pattern hanging in the air. But no one had ever seen light stand still. The equations that described electricity and magnetism refused to allow it. Light in empty space, they said, must always move. That mismatch tugged at him like a soft, persistent riddle. So he turned the question around. Maybe light wasn't the problem. Maybe the problem was how we thought about time and space. From that small turn, the universe opened in a new way. Einstein proposed something radical and simple. The speed of light in a vacuum is the same for everyone, no matter how they move. If that is true, then space and time cannot be stiff and absolute. They must adjust themselves, stretch, compress, bend, so that this one speed stays the same in every viewpoint. What once looked like a single, universal clock became a collection of personal clocks, each ticking according to its own motion. Lengths along the direction of travel became flexible. Time flowed differently for different travelers. From these ideas came what we now call special relativity. It's called special not because it is rare, but because it focuses on one clean case: smooth motion at constant speed, no turning, no speeding up or slowing down. In that calm, straight-line world, Einstein showed that time slows for the fast traveler. Distances shrink along their path, and mass and energy are quietly linked. Out of this web of thinking came a simple, famous line: E equals mc squared. Energy equals mass times the speed of light squared. Just a few symbols, yet they say that mass is a kind of stored energy, and energy has a kind of weight. Anything with mass holds an enormous amount of energy within it, the power of stars hidden inside what seems solid and still. And it all began with a man at a desk, closing his eyes and imagining light. Einstein had no vast laboratory. He had his questions, his patience, and a love of consistency. He trusted that the universe should not contradict itself, that its rules must fit together cleanly. Imagination, for him, was not the opposite of knowledge. It was the tool that let knowledge bend and reveal deeper patterns. As you breathe slowly now, you can almost feel the curve of his thoughts. Motion and time tied together, space and energy part of the same conversation. Each of us carrying our own clock, our own measure of length, our own rhythm different, yet all valid. No single observer owns the whole truth. Truth, in this picture, is shared between perspectives, held together by laws that do not change. It isn't chaos. It isn't anything goes. It is a kind of order gentle enough to allow many views at once, like a lullaby sung in many languages. The words differ, the sounds shift, but the melody stays the same. In the same way, the laws of physics keep their tune even as time and space adjust themselves for each traveler. The cosmos that emerges from this view feels less like a cold machine and more like something soft and responsive, like a blanket that moves with the rise and fall of your breath. Einstein's revolution did not roar. It arrived as a whisper, a quiet rethinking of distance, duration, and motion. From that whisper, much of our modern understanding grew. Those ideas shape everyday things. Satellites that must correct for time dilation so your maps stay accurate, our sense of how energy is locked in atoms, our knowledge that starlight bends when it passes near a massive body. All of it traces back to someone who wondered what it meant to chase a beam of light. Rest for a moment in that thought. One quiet mind, asking patient questions, changed the way we picture reality. By listening to those questions now, you become part of that same gentle shift in understanding. From here, another idea rises on its own. If nothing with mass can move faster than light, and if light's speed is the universe's ultimate limit, what does it mean for reality to have a speed limit at all? You find yourself once more in that imagined ship, alone in deep space. There are no fences ahead of you, no warning signs floating in the dark. The edge is not a place, but a pace. About 299,792 kilometers every second, roughly 186,000 miles each heartbeat of a clock. That is the speed of light in empty space, and nothing with mass. No spacecraft, no body, no stone or storm can ever quite reach it. You can try. You can imagine engines burning as bright as suns, pouring more and more energy into your forward motion. You will go faster and faster still. But as your speed climbs, something gentle pushes back. From the viewpoint of someone watching you, your mass seems to grow. Not like a balloon swelling with air, but as if the universe itself leans against your motion. making each new step of speed harder than the last. The energy you invest no longer goes only into moving faster. It flows into this rising resistance, this deepening inertia. The closer you get to light speed, the more energy you need for smaller and smaller gains. At the limit, you would need infinite energy to match a photon, and infinity is not a resource the universe offers. This isn't nature being unkind. It is nature balancing itself. The speed of light acts as a quiet safeguard. It prevents signals and influences from leaping instantly from one place to another. Every change, every message, every flash must travel. It must ripple through space, taking time. That delay gives the universe structure. It allows causes to come before effects, events to line up in meaningful order. Without such a limit, the story would be very different. A signal could arrive before it was sent. A shadow could fall before the light that casts it. The neat chain of this leads to that would fray. Instead, the universe seems to say, softly but firmly, no faster than this. You can feel that rule, not as a cage, but as a rhythm. This cosmic speed limit gives space its depth and time its texture. It lets you look at the sun and say, the light touching my skin left that star about 8 minutes ago. It lets you gaze at a distant galaxy and know you are seeing it as it was millions of years in the past. The finite speed of light turns the night sky into a kind of memory album, each star a small window into a different moment. Even now, as you lie here, light from faraway suns is sliding through Earth's atmosphere, slipping between leaves, brushing across rooftops, and filtering quietly into your world. Some of those photons began their journey long before you were born. They have crossed gulfs of space within the limit, beat by beat, before landing softly on your eyes. Inside this boundary, the universe holds together. Gravity works. Clocks can tick. Stories can have beginnings and middles and ends. You are not standing outside the rules, looking in. You are woven from them. Maybe that invites a different kind of awe, not from trying to break past the limit, but from seeing how much richness is possible within it. The same law that keeps you from outrunning light also allows you to exist as a creature of time, memory, and feeling. You are moving now, not at the speed of light, but at the speed of thought, carried by curiosity through the fabric of space-time. The same rules that guide photons and planets cradle you as you rest. And as you settle a little deeper into that knowing, you might sense another quiet question forming at the edge of your awareness, waiting patiently for whenever your mind is ready to follow it further. If light always moves with the same steady speed, and nothing can outrun it, that question slowly deepens. What is light really? Not just its pace, not just its brightening of a room, but its nature, its character, its quiet mystery. You let that wondering open in your mind like a small window, and when you look through it, you find yourself again in the dark of space. No breeze, no sound, just the soft sensation of floating in a vast, weightless hush. Across that stillness, something appears. A flicker, a ripple, a traveler. It isn't solid. It has no surface you could touch, no mass you could weigh, no shell to tap with your fingers. It is a photon, a tiny packet of light, gliding through the void. It carries energy across impossible distances. It can warm your skin, feed a leaf, paint the faint pink of dawn and the deep red of sunset. And yet, it is nothing you can hold in your hand or place on your palm. You drift a little closer in thought. A photon is not like a pebble tossed over a pond. It is more like a note from a violin, a vibration moving through a field you cannot see. At the same time, it sometimes behaves as if it were a tiny bead of energy, arriving at a single point on your eye, or on a camera sensor, or on the surface of a mirror. This double life wave and particle is one of the quiet riddles at the heart of physics. Physicists call a photon a quantum of light, the smallest amount you can have. There is no half photon, no smaller slice, but unlike a raindrop or a grain of dust, it never sits still. It has no resting state, no frame in which you could drift alongside it and see it frozen. It exists only in motion. It is born moving and it ceases when it is absorbed. Between those two events, there is no pause. Stranger still, it has no mass at all, yet it carries energy and momentum. When it strikes something very gently, very lightly, it can push, warm, or knock an electron into a new state. It isn't made of light, it is light. Not a beam, not a glow, but the basic unit of what we call brightness and color. Even calling it a particle is only half the truth. Shine a flashlight, and you don't picture tiny pellets flying into the dark. You picture a beam, a smooth, spreading column of illumination. At a deeper level, what leaves the flashlight is a ripple in electric and magnetic fields, spreading out as a wave. These waves curl and stretch through space like invisible threads, weaving a pattern of energy. Light, then, is both. In some situations, it behaves as a spread-out wave, interfering and overlapping with itself. In others, it arrives in discrete packets, as if it were a stream of tiny hits. It does not choose one or the other ahead of time. It is simply ready to show the side that your way of looking calls out. You might remember, or gently imagine, an experiment with two narrow slits and a screen. Light is sent toward the slits and allowed to pass through. If it were just a swarm of little particles, you might expect to see two bright bands where they land. But what appears instead is a pattern of many bright and dark stripes, like ripples from two stones dropped into water, overlapping and canceling. That is the signature of a wave. Then, when detectors are placed to watch which slit the light passes through, the delicate pattern fades. The result begins to look more like simple spots, as if the act of watching has nudged light into a different costume. It can feel almost personal, as if the universe is shy under observation. You don't have to solve this tonight. You don't have to decide whether a photon knows it is being watched. You only need to let the mystery exist. That reality allows something to be both spread out, possibility, and pinpoint arrival, and that looking at it can change what you see. All around you, photons are streaming every moment. The glow of your screen, the soft light in your room, the distant shimmer of stars, even the faint warmth of your own body, all are sending out these tiny, massless travelers. They pour down from the sun, radiate from hot surfaces, slip between atoms, and bounce from wall to eye to thought. They never rest. That is part of what makes them so strange compared to you. You, with mass, can stop. You can lie still, close your eyes, let your muscles soften. You can choose a moment of non-motion. A photon has no such pause. From the instant, it is created by an excited atom on a burning log, by the surface of a star, by a transition inside a distant galaxy. It moves forward at its one speed. There is no slower setting. From your point of view, its journey takes time. It leaves the sun, crosses millions of kilometers, and 8 minutes later touches your face. It leaves a galaxy, streams through space for millions of years, and only then reaches your telescope. But from the photon's point of view, if it could have one, something very peculiar happens. Because it travels at the speed of light, time does not pass for it at all. The moment of creation and the moment of absorption collapse into a single, timeless event. To you, it travels. To itself, it simply is. You lie with that thought for a while, thinking of something that has no weight, no ticking clock, and yet defines every sight you've ever had. It becomes subtler. Not all photons carry the same energy. Those we call radio waves have long, gentle wavelengths and lower energy. Those we call gamma rays have tightly packed waves and much higher energy. In between lie microwaves, infrared, visible light, ultraviolet, X-rays, a whole spectrum of frequencies, all moving at the same speed, differing only in how quickly they oscillate and how close together their wave crests sit. A photon of blue light has more energy than one of red. Its wavelength is shorter, its song tighter and higher. Ultraviolet light is more energetic still, infrared, softer and lower. So when you see a rainbow arched across the sky, you are not just seeing pretty colors laid side by side. You're seeing energy arranged by frequency, photons sorted by the tune they sing. And here's an even softer truth. You don't really see light itself. You see what light does. You see the way it bounces from surfaces, is swallowed by pigments, re-emitted by atoms. You see patterns of reflection and absorption, shadows where it cannot reach, glows where it lingers. Light is the storyteller of vision, not the story. It whispers the outline of trees, the shimmer of water, the curve of a loved one's face. It brings you the quiet glow of a book cover, the silver trace of moonlight on a floor, the pale blue washing the morning sky. But light, passing unseen through empty space, is invisible unless it finds something to dance with: a particle, a surface, a retina. So you float now in the idea that your world is filled with silent visitors. Invisible waves and tiny quanta move through you, around you, all the time. Most go unnoticed, slipping by without a trace. Only when they touch, when they are caught or scattered, do they leave a mark in your awareness. And through these countless interactions, light becomes your main messenger from the wider universe. Every star you have ever glimpsed is speaking to you in photons. Each flicker of starlight is a message about where it came from, how hot it is, how fast it moves, how old its light has become. When you look up, you are reading ancient mail. Thinking of photons as messengers naturally brings you back, gently, to the matter of time. If these tiny, timeless travelers can cross such gulfs to tell you about distant stars, what does that say about the time you live inside? How does your own, slower, heavier body move through the same universe? To explore that, let your mind sketch a different scene. You imagine two hearts beginning life together, two twins sharing the same first cry, the same early memories, the same easy laughter. You picture yourself as one of them, lying still here, breathing quietly. The other twin, your mirror, steps into a silent ship and rises into the sky, slipping beyond clouds, beyond Earth, into the deep, dark. This is the classic twin story, not a contradiction, but a thought experiment, a gentle way to feel what happens to time when it is asked to bend. You stay on Earth as days pass and seasons turn, as familiar clocks keep their patient beat. Your twin travels faster and faster, their ship gliding close to the speed of light. Inside their vessel, life feels normal. They eat, sleep, dream, watch distant stars drift by, but something unseen is happening. Their time is slowing compared to yours. Not in their own experience, their heart still beats at its usual pace. Their thoughts move at their usual speed. But if you could watch their clock from afar, you would see it ticking more slowly than the clocks around you. You send radio messages into space. Where are you now? How are you? The answers return. Still young, still mid-journey. You plant gardens, celebrate birthdays, watch the moon wax and wane. You begin to see new lines at the corners of your eyes in the mirror. Years later, their ship returns. It glides down through the atmosphere, lands, and opens. Your twin steps out, eyes bright, face smoother, body younger than yours. The two of you embrace. The difference is startling but real. You have lived more time than they have. This isn't magic. It's the same time dilation you imagined earlier, taken to an extreme. Moving close to the speed of light stretched your twins' time like warm taffy, slowing their aging relative to yours. They experienced fewer seconds for every minute that passed on Earth. You might wonder why it couldn't be the other way around. If all motion is relative, why not say they were still and you were the one moving? The quiet answer lies in the moments when their ship turned around, when engines fired, when they felt acceleration. Those changes in motion mark their path as different from yours. Their journey through space-time is not the same straight, gentle curve as your life on Earth. Einstein used the phrase proper time to describe the time measured along a particular path through the universe. Your path, your world line, stayed close to Earth, close to its gravity and steady rotation. Your twin's world line left, bent outward into the high-speed realm, then turned back. Each path carries its own amount of proper time, its own total of lived moments. You can picture space-time as a vast, four-dimensional map of where and when every person, every object, every photon draws a line through this map. These are world lines, not drawn in ink, but traced by existence itself. Your world line has covered more time between the day of your shared birth and the day of reunion. Your twin's world line has taken a shortcut through time by skimming near light's limit. There is a tender feeling tucked inside this idea. Time is the medium in which you love, remember, grow beside others. To think that two people who began together can reunite having lived different amounts of time is both strange and quietly moving. It isn't science fiction. The effect has been tested in small ways, with speeding particles and flying clocks and satellites circling Earth. Those satellites that help your phone find its position are tiny echoes of the twin story. Their clocks tick a little differently than clocks on the ground, influenced by both their speed and the weaker gravity they feel. Engineers must account for both effects. If they ignored them, your map would slowly drift, and the directions guiding you home would wander off course. You live inside this gentle dance of time without noticing it, from one heartbeat to the next. Yet it's always there, shaping the paths of planets, the lives of stars, the aging of astronauts, the flow of signals around the globe. The twin thought experiment becomes more than a clever puzzle. It becomes a way to see yourself as a traveler too, even when you never leave the surface of Earth. Your own world line is unwinding now, a soft curve through space-time. Each breath, each memory, each quiet moment like this one adds another small segment to it. Somewhere in your imagination, your twin is stepping out of the ship, younger in years, but no less changed by the journey. Time has treated you differently, but it has brought you back to share a present moment. And maybe that is the gentlest point of all. Time may stretch and fold, clocks may disagree, photons may cross ages in a single timeless leap, but there is still the possibility of meeting again, of sharing a now. In that shared now, The differences soften, and what remains is the simple, steady feeling of being here, together, inside a universe where light and time quietly shape every story you tell. You rest, letting your pulse soften, and notice a new question rising quietly under the surface. If time can stretch and space can fold, and if light glides through all of this unchanged in speed, what else does it carry? What hidden shades ride on its waves? Colors that never reach your eyes? Songs too soft for your senses to hear? You let your thoughts drift to color, not just one hue, but a gentle sweep. Deep red, soft gold, green leaves in sunlight, indigo sky after rain. Every sunset, every stained glass window, every glow behind your eyelids is made from waves of light within a narrow band. Tonight you slip beyond that band, past the edge where your sight stops, into regions where light continues, but your vision lets go. What you call color is only a tiny window in a vast sea of electromagnetic waves. Light is more than what you see. It is energy, motion, rhythm. Your eyes, remarkable as they are, can only notice a small range of wavelengths, roughly from about 400 to 700 nanometers. Shorter waves than that are called ultraviolet. Longer ones are called infrared. Both are fully real, fully light, just outside your built-in tuning. So you begin at the red end and drift gently longer. You pass the familiar glow of crimson and scarlet and slip into the warmth of infrared. Here the waves are longer and slower than visible red. You cannot see them, but you feel them as heat, the comfort of sunlight on your cheek, the warmth of a mug between your hands, the gentle radiance of another person sitting nearby. Infrared is a lullaby of warmth, wrapping the world in an invisible, soft blanket. Some creatures can sense this directly. Snakes track prey in the dark by feeling their infrared glow. Night vision cameras turn this hidden light into images. Astronomers use infrared telescopes to peer into dusty clouds where stars are being born, regions where visible light is blocked, but infrared threads its way through. You float through this quiet red twilight, imagining your own body glowing gently in infrared, like a candle seen by eyes tuned to heat. All around you, every object warmer than absolute cold is sending out these long, invisible waves, whispering its presence. Drifting further, the wavelengths stretch. You pass through microwaves, the gentle waves that hum in your kitchen, that also fill all of space with the faint afterglow of the early universe, the cosmic microwave background, that ancient echo of the first light that could move freely. Wider still, and you reach radio waves, huge, slow undulations that can be meters, even kilometers long. They wrap around mountains, slip through walls, carry voices and music and signals from distant spacecraft. You move through them as if through water, each wave a soft hand brushing by, unnoticed but everywhere. Then your thoughts turn back toward the visible band, passing again through red, orange, gold, green, and into blue and violet. Beyond the violet, the waves grow shorter and tighter. This is ultraviolet, light too energetic for your eyes, but familiar to bees and butterflies. To them, petals carry glowing patterns, landing strips of color you cannot see, painted in ultraviolet ink. This light can tan your skin, repair or damage DNA, and mark feathers and wings with secret signs. Shorter still are X-rays, with enough energy to slip through soft tissue and bounce from bone, sketching the hidden scaffolding inside your body. Hospitals use them to look beneath the surface, stars and gas clouds, use them to announce violent, high-energy events in space. Shorter again are gamma rays, light from the most extreme processes, the deaths of massive stars, the decay of radioactive elements, eruptions in far-off galaxies. These are the sharpest, most energetic waves, rare and fierce, clicking softly in detectors that wait for their brief arrival. You drift through this silent hierarchy and realize it is all the same family. From slow radio waves that stretch across landscapes to fierce gamma flashes from distant cataclysms, it is all light, different frequencies of the same electromagnetic dance. Light is not a single note. It is a full symphony. Your human eyes are tuned to just a thin, fragile octave in the middle. You are like an instrument with only a few working keys, yet the universe plays a grand, many-layered song around you. Some birds see ultraviolet edges on leaves and feathers. Certain fish see patterns of polarization in water. Tiny shrimp with complex eyes may distinguish colors you have no names for. You are not blind. You are simply limited hearing the melody but missing many of the harmonies. And yet you find ways to listen. You build telescopes that see in infrared, radio dishes that catch long waves from space, X-ray observatories that watch hot gas swirl around black holes, gamma-ray detectors that wait for brief, powerful bursts. Spectrometers spread light into rainbows and reveal the fine lines within. These tools stretch your senses. Through them you discover star nurseries hidden in dust, jets of particles near black holes, the glow of galaxies forming in the early universe. All of it is light you cannot see directly, but light that has always been there. You lie still, wrapped in the gentle thought that the world you know is only a slice of what surrounds you. Invisible colors and energies are constantly flowing through space, passing through your room, your body, your mind. They do not require your awareness to be real. They simply are. You take your place within this spectrum too. Your warmth glows in infrared. Tiny electrical pulses in your brain generate faint fields. Your body absorbs and emits, receives and sends. You are not outside the dance. You are one of the dancers. Breathing softly, you let another question surface. If light comes in all these forms and crosses such vast distances, what messages does it carry? What stories are wrapped up in each wave and photon? Where do these ancient travelers come from? And what have they seen? Light has no voice, yet it speaks to you. Every star you glimpse is a conversation. Every shimmer on the ocean, every faint smudge of a distant galaxy is a sentence in a language of waves. You listen not with ears, but with imagination, and with the quiet detectors of your eyes and instruments. A photon's story often begins deep inside a star, in the core of the sun or another glowing sphere. Temperatures and pressures are so extreme that hydrogen atoms are pressed together to form helium. This process, nuclear fusion, releases energy. Some of that energy emerges as photons, born in a storm of particles and light. At first, they cannot escape. The interior of a star is crowded and opaque. A newborn photon travels only a short distance before being absorbed by another particle and then re-emitted in a new direction. Step by tiny step, absorbed and released over and over, an individual packet of energy may spend thousands or even millions of years wandering the stellar interior, slowly working its way outward like someone threading through a dense crowd. Eventually, it reaches the surface. Then, at last, there is open space. Freed from the star's thick layers, it flies outward at the speed of light into the cold, thin dark where almost nothing stands in its way. From there, its journey is simple. One speed, one direction, unless something deflects it. Some photons will travel only a short distance to a nearby planet, to dust, to a passing grain of rock. Others will set off across interstellar space, crossing the gulf between stars, then the valleys between galaxies. They travel without engines, without memory, without steering, moved only by the initial push of their creation and the shape of space-time itself. If conditions align, if the photon's path and your position happen to match its journey ends in your eye, right now, if you look at a star, you are catching photons that may have left their source long before you were born. Some may have begun their travel before humans existed, before any eyes on Earth were capable of seeing them. If you look toward the Andromeda galaxy, the faint smudge you see is made of light that started its trip about 2.5 million years ago. Stars closer to home send light that left decades or centuries ago. You are not just seeing distant things, you are seeing them as they were. Light does more than show the world, it records it. It preserves snapshots of distant moments and carries them forward in time. Some of the stars you see tonight may already be gone. Their lives ended in quiet, fading, or brilliant explosions, but their earlier light is still on the road, still arriving, still painting memories across the sky. You might imagine each photon as a tiny letter, carrying a single syllable of information. Your eyes, your skin, your telescopes are pages where these letters land. Astronomers read them with great care. They split starlight into its rainbow and examine the fine, dark, or bright lines that thread through it. Each chemical element, hydrogen, helium, iron, oxygen, leaves its own pattern, a unique signature. By studying these patterns, scientists learn what stars are made of, how hot they are, how fast they spin, whether they are moving toward us or away. This careful reading of light, called spectroscopy, turns the night sky into a library. From those lines, we learn of stars exploding as supernovae, scattering heavy elements into space. We find planets around distant suns, not by seeing the planets directly, but by noticing tiny, regular wobbles in the star's light as the planet tugs on it. We trace the swirling arms of galaxies, measure the pull of black holes, and map the expansion of the universe itself, all by listening to what light has written into its own waves. You may never point a telescope at the sky, but you are still part of this exchange. With every glance upward, every moment spent watching a sunset or the quiet glimmer of a star, you are accepting light's messages. Even without equations, you feel what it means. That there is more beyond, that the universe is wide, that you are small and yet somehow included. Light crosses the darkness without maps or guides, a thread of energy connecting distant stars to your retinas, distant epochs to your present moment. You are not merely a receiver, you emit your own faint glow. You absorb and transform energy. You add your own warmth to the world. Somewhere, even now, a photon that left your cheek might be on its way through space. It may drift for ages, pass uncounted stars, and one day fall softly onto the soil of another world. A quiet, weightless messenger from the person who once lay here and breathed in this moment. You rest inside that thought. Light is not just brightness, it is memory, motion, meaning. It speaks without sound, in the simple fact of being there. Once you begin to recognize its voice, another question naturally rises. What happens to this light when gravity reaches out? Can something with no mass still be guided, turned, curved? You let your mind float outward again, into the vastness, and picture space not as empty blackness, but as a soft fabric stretching in every direction, flexible, gentle, able to sag and ripple. This isn't only a metaphor, Einstein showed that anything with mass stars, planets, even your own body presses into this fabric and curves it slightly. The more mass, the deeper the curve. In such a universe, light does not travel along straight lines the way a ruler might suggest. It moves along the straightest possible paths in a curved world. Those paths, called geodesics, bend with the fabric itself. Light is not being yanked or slowed. It is simply following the shape that space and time provide. This bending is called gravitational lensing. It's not just an idea on paper. Over 100 years ago, during a solar eclipse, astronomers watched starlight pass near the edge of the darkened sun. When they compared the stars' apparent positions to where they normally appeared, they saw a delicate shift. The stars had not moved, but their light had curved. The sun's gravity had warped the space around it, and starlight followed that gentle bend on its way to Earth. That slight deflection was enough to confirm something astonishing. Space and time are not rigid. They are fluid and responsive. Mass tells space how to curve. Curved space tells light how to travel. You drift now in imagination to a massive galaxy far away, heavy with stars and dark matter. Behind it, even farther out, lies a small quasar, a tiny blazing core of a distant galaxy. Light from that quasar travels toward you, but on the way it passes near the massive galaxy and the curved space around it. Some of the light takes one path, some takes another, all following the warped fabric. By the time it reaches Earth, the quasar's light may appear in several places at once, as arcs, multiple images, or a delicate ring around the foreground galaxy. The galaxy acts like a lens, bending and magnifying the distant glow. Telescopes have captured these ghostly structures, soft halos, and stretched smears of light, wrapping around invisible centers of gravity. Even black holes, the densest objects we know, shape light in extreme ways. Their gravity is so strong that inside a certain boundary, no path leads outward. Any light that crosses that threshold cannot escape. But just outside, in a region called the photon sphere, light can circle. A photon there can orbit the black hole, racing around it in an endless loop, neither falling in nor flying away, caught in the perfect balance of curvature. You can imagine a single beam of light, looping again and again around that dark center like a thought that keeps returning to the same memory. You might ask how gravity can affect something with no mass at all. The answer lies in shifting perspective. Gravity, in Einstein's view, is not a force pulling from a distance. It is the shape of space-time itself. Light doesn't feel a tug. It simply moves along the paths that exist in the curved geometry. A marble, rolling on a warped cloth, isn't being pulled sideways by an invisible hand. The cloth itself dictates the path. When you see light bend around a star or cluster of galaxies, you are watching the architecture of the cosmos made visible. The invisible curves of space-time are traced by glowing lines of photons, outlining a structure you cannot touch but can infer. Even here on Earth, the sunlight that reaches you does not travel in perfect straightness. Its path is ever so slightly bent by our planet's gravity, and then again as it passes through the atmosphere. The effect is tiny, but it's there, light, always listening to the shape of space. In this understanding, light and gravity are intertwined. Gravity shapes the paths that light may take. Light reveals where gravity is strong, where matter and even unseen mass gather. Telescopes use this partnership to map things that do not shine at all. When starlight curves in ways we cannot explain with visible matter alone, we infer the presence of dark matter, something that does not glow, but still bends the fabric. In that sense, Light becomes an artist's pencil, sketching the outlines of the invisible. You rest in this quiet balance, what moves and what curves, what shines and what pulls. Every time you look up at the night sky, your eyes are catching photons that have followed twisted paths around stars, clusters, and clouds. The picture you see is not a simple straight-line view, but the result of a graceful choreography between light and gravity. As your breath grows slow, you might sense something more intimate. This bending and shaping of light is not only happening out in distant galaxies, it is happening within you. Light travels through your body. It is bent by your eyes, filtered by your tissues, absorbed and scattered, and turned into signals. Your ability to see, to wake, to feel the difference between day and night, all of it depends on the way light is guided inside you. So your attention turns inward. Right now, as you lie here, photons are slipping through your window, scattering off walls, brushing your skin, some passing through your closed eyelids. Most are gentle and harmless, soft emissions from the sun and sky. They are not just brightness, they are tiny deliveries of energy, parts of the same process that keeps life on this planet alive. You follow the path of light as it meets your skin. This is where sun and self first touch. High-energy ultraviolet photons can stir cells into action. Some of them set off chemical chains that help your body make vitamin D, important for bones, immune function, and quiet systems you rarely think about. Sunlight slowly becomes part of your chemistry, folded into who you are. Too much light can harm, too little can weaken. As with so many things, there is a balance. Deeper in, some photons are absorbed by melanin, the pigment woven through your skin. Melanin acts like a soft shield, catching and dispersing energy before it reaches more delicate layers. It is a protective net, allowing some light through, turning others aside. The photons that do pass further sink into tiny blood vessels near the surface. Red blood cells take in their warmth, and your tissues absorb subtle energy. In this way, sunlight doesn't just touch you from the outside, it gently warms you from within. You move your attention to your eyes, the clearest doorway for light into your body. Imagine them open. Every moment, streams of photons enter through your pupils. Your cornea and lens bend and focus the incoming light, much like a small telescope, curving the rays so they come together on the back of the eye. There, on the curved layer called the retina, something almost magical happens. Light becomes electricity. The retina is lined with tiny photoreceptor cells, rods, and cones. Cones are sensitive to different ranges of color, roughly red, green, and blue, while rods handle dim light and motion. A single photon can sometimes trigger a response in one of those cells. When it does, a cascade of chemistry turns that event into an electrical signal. These signals travel along the optic nerve into your brain, where entire regions work to turn them into images. Your brain flips the picture, sharpens edges, fills in gaps, adds expectations and memories. You don't simply receive light, you interpret it, creating a world from streams of photons. Light also touches a quieter part of your brain, the one that keeps time for your body. Behind your eyes, special cells respond to brightness, not for seeing, but for setting your inner clock. They send signals to a tiny region called the suprachiasmatic nucleus, which coordinates your daily rhythm. Morning light tells your body to wake, to release alertness. Evening darkness signals the release of melatonin and prepares you for sleep. If you travel across time zones or spend days away from natural light, that rhythm can slip. Jet lag, fatigue, And mood changes are your body's way of asking to find the sun again, to recalibrate to its gentle cues. You are not separate from daylight. You are tuned to it, built to respond. Beyond these familiar paths, skin, eyes, clock, light influences you in subtler ways. Photons can affect how certain genes are expressed, how cells repair themselves, how energy is handled. Therapies use specific wavelengths, red and infrared light to soothe inflammation, blue light to help with certain sleep problems, full-spectrum lamps to ease the gloom of dark winters. Your body listens to light with more than just sight. And just as you receive light, you send it. Your skin and body emit infrared radiation, the warmth a sensitive camera can see. In a dark room, viewed through such a lens, you would appear as a soft, glowing shape. You are, in a small and constant way, a lantern. Deep in your brain, there may even be tiny, ultra-faint flashes of light called biophotons, whispers of photons released during certain reactions in neurons. We don't fully understand their role yet, but the idea that the mind might quietly glow is a tender one. You lie here now, not just bathed in light from outside, but participating in the exchange. Your atoms were forged in ancient stars. Your moods sway with the pattern of day and night. Your cells respond to photons. Your warmth shines back. Light crosses galaxies and bends around suns, but it also crosses you, enters, shapes, and leaves again. It shows you the world, and when it reflects from your face, it shows the world you. You've just followed light as it moves through you, warming, guiding, and quietly leaving again. Now your thoughts turn to the moments when it comes back. A photon leaves your skin or the surface of your eye and drifts into the dark. It may travel for years, glide between stars, skim dust and ice, and one distant day it could fall onto another world's ground. A tiny messenger from the person who once lay here in this quiet. Rest with that for a breath. Light is not only brightness, it is memory in motion. It carries traces of where it has been, of what it has touched. Sometimes it goes outward and never returns. Sometimes it comes back home. You drift toward that returning now, toward mirrors, reflections, and the soft beauty of seeing light twice. Light doesn't decide, but it doesn't always rush straight ahead. Sometimes it is turned. Sometimes it is delayed. You can sense a hint of this with your eyes closed, noticing the faint glow behind your eyelids after a lamp is switched off. That lingering image is light's echo inside your senses, a reflection held in your own perception. Picture a simple mirror on a wall, flat, quiet, almost nothing until something shines on it. When light from your face reaches that surface, photons hit the thin metal behind the glass and bounce away. They follow a gentle rule. The angle in equals the angle out. The mirror doesn't invent your image. It simply returns the light you've sent. Your brain does the rest. It assumes those rays have traveled in straight lines from somewhere behind the glass, because that's what light usually does. So you see another you, hanging just beyond the surface, as if there were a second room tucked inside the wall. In truth, there is only one room, one body, and light leaving and returning. Reflection is not just for faces. It is one of the ways we listen to faint things. A reflecting telescope uses a curved mirror to gather thin starlight from far away and bring it to a focus, like a whisper cupped to your ear. With mirrors like these, we see galaxies that bloomed before Earth had oceans and starbursts that ended long before human eyes existed. High above you, Large space telescopes unfold their mirrors to catch faint light that has traveled for billions of years. Those reflections let us glimpse the first stars and the early shaping of galaxies. The moon is a mirror of a rougher kind. It does not shine on its own. Its glow is borrowed sunlight. The pale silver on your skin at night is light that left the sun, touched the moon's craters and dust, and then came down to you. Earth reflects too. Oceans, clouds, and ice send sunlight back into space. From far away, a telescope could read these reflections as hints about water, weather, even life. In a way, reflection is how the world remembers its own surface. Light is sent out in all directions. Some of it returns. In the way it bounces, it tells of smoothness or roughness, of angle and texture, of color and motion. A perfect mirror gives back a sharp image. A calm lake returns a trembling copy. A leaf, a stone, your skin scatter light in many directions, softening shadows and making brightness seem to come from everywhere at once. The word reflection belongs to thoughts as well as photons. To reflect is to send an idea back through your mind, to look again, to see from a new angle. You're doing that now, turning over what light is, how it moves, how it touches you. The universe reflects in mirrors, you reflect in memory. Sometimes, reflection can be arranged to last. Two mirrors facing each other create a tunnel of repeating images. In carefully built cavities, light is trapped between reflective surfaces, bouncing many times before it finally fades. The energy becomes a sustained whisper, a rhythm held in motion. Feeling all this, you start to sense space itself differently, not simply as empty distance, but as something that carries journeys and returns. The gaps between stars are not just dark stretches, they are lengths for light to cross. Here, a familiar phrase begins to glow in your thoughts. Light year. It sounds like time, as if someone had stretched a year along a ruler. But a light year is not measured on a clock. It is measured in space. It is the distance light travels when it moves at its steady pace for one full year. Light races through a vacuum at about 299,792 kilometers every second, roughly 186,000 miles, in the time it takes you to blink. In a single second, it could circle Earth several times. Imagine it continuing without pause for a year. The length of that path is what we call a light year, almost 10 trillion kilometers, about 6 trillion miles. The numbers are so large they stop feeling like quantities and become more like a kind of vastness. Instead of memorizing them, you can feel what they mean. Picture a single photon born in the heart of a distant star. From that first moment, it moves at light's constant speed, never resting. If nothing blocks it, it will cover 1 light year of distance in 1 year of your time. Out in space, that span becomes a natural unit. When kilometers feel too small, the universe speaks in light years. So when someone says a star is 4 light years away, they mean its light has spent about 4 years crossing the gulf between that star and your eyes. You see it not as it is now, but as it was 4 years ago. The photons that touch you tonight left back then carrying an earlier version of its face. The Andromeda Galaxy's glow has been traveling for around 2.5 million years. Some distant beacons send light that has been on the road for more than 13 billion years. When that light arrives, it carries an image of a universe still very young. Seen this way, the night sky becomes a kind of time machine. Each point of light is a window into a different when. You do not move through time to visit these moments. They come to you, carried patiently by photons. Between all those distant sources, the space may seem empty, but it is not empty of journeys. Some photons will glide for billions of years without ever striking dust, rock, or eye. They simply keep going, their stories never read. Most stars are unimaginably far. Galaxies are spaced by millions of light years. Yet the light from those regions is already here, landing on mirrors, slipping through your atmosphere, sometimes brushing your skin as the faintest warmth. There is a quiet puzzle in this. Light years are units of distance, yet every measure of how far includes how long ago. A star's distance tells you how many years its message has been traveling to reach you. You do not have to go to these places yourself. By the time their light arrives, you are already standing in the right place to receive it. The universe comes to you on light's back. Astronomers use this to read the early history of everything. By looking farther away, they look deeper into the past, catching light that set out when stars were first forming, when galaxies were young, when space itself was denser and hotter. Their telescopes become instruments of memory as much as sight. You can join that quietly by imagining the light that leaves you. Every moment, photons stream away from your skin, your hair, your breath. If someone, somewhere, far in the future and far away, were to point a sensitive telescope exactly toward where you once were, they might gather a few of those old photons. To them, you would be a tiny pattern of light from long ago, a gesture, a smile, a still figure thinking about the speed of light. So when you hear the word light year, you can think of more than distance. You can think of continuity, of messages in motion, of memories crossing the dark. The wide spaces between stars are not empty after all. They are filled with light, traveling, reflecting, returning, carrying the stories of suns, of worlds, and, in some small way, of you. If light can cross trillions of miles and carry memories from the hearts of stars to your eyes, it's natural to wonder about the places it doesn't reach, the soft edges, the quiet gaps. What is darkness, really? What is a shadow, if not just less light? You lie quietly, wrapped in all the stories light has told so far, its speed, its colors, its journeys through time. Now you slip into what light leaves behind, the gentle companion that follows it everywhere. Shadow. We often speak of shadow as emptiness, as what remains when light is gone. But a shadow is not nothing. It has shape. It has boundaries. It is drawn by presence, by angles, by the way light and matter talk to each other. Close your inner eyes and picture the warm light of a setting sun spilling through a window. Golden beams reach across the floor, climbing over furniture, fingers of brightness stretching thin. Between those beams lie areas of dimness, not true voids, not holes in reality, but places where light has been blocked, bent aside, or absorbed. A hand, a leaf, a mug on a table, all of them say to the light, "Not here." And in that conversation, the shadow appears. Light, so swift and subtle, is easily stopped by the simplest things. A stone, a curtain, your own body. Where it cannot go, a soft outline forms. Shadows trace the edges of what exists. They mark the presence of shape, the curve of a cup, the fold in a blanket, the line of your cheek. In doing so, they reveal light itself. Light on its own, moving through clear air, is invisible. You only notice it when it touches something, when it is interrupted. Shadows make the bright parts stand out. The dark makes the light clearer. This quiet dance between illumination and blockage plays out on a cosmic scale, too. Imagine a solar eclipse. The moon slips between Earth and the sun, lining up just so. Its shadow touches the planet, and for a brief time the day dims to an uncanny twilight. Birds go silent, the air cools, people look up in awe. That hush is created by geometry, one circle of rock blocking the light from a distant sphere of fire. In deep space, shadows slide slowly across moons and rings, marking the passage of days on worlds without air. Saturn's rings, made of countless icy fragments, sparkle in the sun. Look closely in pictures, and you can see their shadows falling onto the planet's cloud tops, like delicate brushstrokes. As Saturn moves and the sun's angle changes, these shadows shift and lengthen. Nothing is fixed, everything glides. Comets throw dark tails behind them where dust blocks sunlight. Earth itself casts a long, tapering shadow out into space. The moon sometimes drifts through it, turning red in a lunar eclipse as sunlight skims through our atmosphere and paints it with color. Even here, darkness is not empty. It is structured, a quiet half of a larger event. You, too, cast a shadow right now, even if it's faint, erased by soft room light. It's proof that light is touching you and being turned aside. As you move, your shadow moves. A reminder that light is not just still radiance, it is direction, change, interaction. Even your inner life knows something of shadow. There are times when joy feels blocked, when clarity dims, when you stand behind some large worry or sadness, waiting for the light to come back around. That, too, has shape. Emotional shadows tell you where the light used to be and from what direction it might return. As the days change, so do those shadows. Nothing stays hidden forever. Light and shadow are not enemies. They need each other. One defines, one outlines, one reveals, one rests. Together they give depth to what you see and feel. Even in quantum experiments, the idea of shadow finds a strange echo. In the double-slit setup, when no one checks which path light takes, it behaves like a wave exploring every possibility, leaving a smooth interference pattern of bright and dark bands, as if there were no clear shadow of where it did not go. But when detectors are placed to watch which slit each photon passes through, that pattern changes. The soft spread of possibilities tightens into solid lines. Observation carves out a structure, a kind of pattern shadow, in the space of what could have been. Awareness leaves a mark, not just on your thoughts, but on the way reality shows itself. You are both light and the outline it casts, the energy that moves and the shape it leaves in the world. The actions you take, the words you speak, the silences you keep, they all create patterns, bright and dark, in the lives around you. And deeper still, in places where sunlight never reaches the ocean's floor, the heart of dense stars, the inner corners of caves' existence continues. Some fish have no eyes. They feel their world by touch and current. Some creatures grow lights of their own, tiny lanterns in black water. Some roots and fungi live in slow patience, nourished indirectly by energy that began as light long ago. Shadow is not the end of the story. It is a quieter chapter. So as your room darkens and the shadows stretch, you can think of them not as empty, but as signs, proof that light was here and is still here, just redirected. You lie partly in shadow now, but you're surrounded by every photon that missed you, bounced past you, or will arrive later. Light and its absence trace your outline on the world. From this gentle place, another question approaches one you've met before, but that now feels deeper. If light moves like a wave and also arrives like a particle, what is it really? You've watched it scatter into colors in a rainbow, bounce from mirrors, bend around gravity, switch your inner clock, and warm your skin. It feels so familiar, but whenever we press it to define itself, it slips into a paradox. Light offers not one face, but two. You can begin with the wave. It's easy to picture waves, ripples in a pond, vibrations in a guitar string, sound rolling through air. Waves have frequency and wavelength, how often they crest, how far apart those crests are. Light behaves this way. Blue light has shorter, tighter waves. Red light has longer, more relaxed ones. When light passes through a prism, different wavelengths bend by different amounts and spread into a rainbow. That's a wave unfolding into color. Waves can overlap and interfere. Drop 2 pebbles into water and watch the ripples meet. In some spots, they add up to higher peaks. In others, they cancel to calm. Light does exactly this. In the famous double-slit experiment, when a beam or even single photons one by one passes through 2 narrow openings and no one checks which path each one takes, the pattern on the screen is a series of bright and dark bands. That is the signature of a wave interfering with itself. But the moment you try to catch light in the act, something changes. Place tiny detectors at the slits to ask, which way did you go? And the interference pattern fades. Instead of many thin bands, you see 2 main clusters, as if each photon chose one slit or the other and traveled like a little pellet. It's as though the question you ask matters. Watch for paths, and light answers as particles. Ignore the paths, and light answers as waves. This isn't a trick in the apparatus. It's how the world behaves at very small scales. Light can spread out as a wave of possibility, then arrive as a specific event, a photon hitting a screen, a sensor, your retina. In practice, we use both pictures. Engineers designing fiber optic cables think of light as a wave guiding information along glass threads. Scientists building solar cells think of light as photons, tiny packets of energy knocking electrons loose. Lasers, LEDs, camera sensors, diffraction gratings all rely on different aspects of this twin nature. To hold both truths at once, physics developed a new language, quantum mechanics. In this view, a particle is not a tiny marble. It is a cloud of probabilities, a spread of where it might be, how it might behave. Until an interaction forces a choice, the photon is not here or there, this path or that path. It is described by a wave that includes all the ways it could exist. Measurement any kind of definite interaction narrows that wave into one specific outcome. The photon travels as a probability wave. It arrives as a definite event. You may feel a bit of ground shift under you with that idea. That's all right. You don't have to turn it into something familiar, like a stone or a chair. You can simply let the strangeness sit beside you, gentle and unresolved. In a way, this duality isn't only about light. You might recognize something of yourself in it. You too can be more than one thing at once. Calm, but curious. Tired, yet hopeful. Sad and grateful in the same breath. Your inner life doesn't always fit into single, neat labels. Like light, you contain possibilities, some of which become visible only in certain situations. The fact that light is both wave and particle is not a failure of understanding. It's a reminder that the universe is layered. that some truths depend on how we look, what we ask, and how gently we listen. So you drift now in that space between pictures, between wave and particle, between spread and point, between everywhere it might be and here it actually is. You imagine a photon again, leaving a star, journeying for 1 billion years as a broad, quiet wave across expanding space. Then, finally, it meets an eye, a mirror, a detector. In that moment, its long story narrows into a single touch, a single spark. On the way, it was a wave of possibility. On arrival, it is a particle of light. The story changed not because reality flipped, but because of the way it revealed itself, because of how and where it was finally seen. Because you look, because you listen, you become part of the story. Every time you ask how light behaves, you step into its rhythm. You're not standing outside the universe, watching it like a distant stage. You're inside it, woven into the same fabric you're curious about. Your questions are also events, small ripples in the pattern. You can rest in that paradox. You don't have to pick a single answer. You don't have to force the world into one neat picture. You're allowed to float in the in-between, the way light does, sometimes a wave, sometimes a particle, always a little beyond simple description. And as you drift there, another thought begins to glow at the edge of your awareness. If light is the fastest thing there is, the ultimate limit, what does it mean when something seems to jump ahead of it? Can anything truly outrun that cosmic speed? Or are there ways of moving, ways of knowing, that don't fit into distance over time at all? You lie still, letting that question open gently. You've learned that no physical signal, no rocket, no radio, no whisper can travel faster than light. That limit keeps cause before effect and holds the universe together in a coherent story. But there are hints of other kinds of motion, things that stretch what you mean by speed without tearing the rules. The first of these is as close as your own mind. Close your eyes and think of a star, any star you like. See its color, its position in the sky. Now think of another, farther away. Maybe a faint red point near the horizon, or a bright white one overhead. Your attention moves from one to the other with no delay. You didn't have to travel between them. You didn't cross the billions of kilometers in between. Your awareness simply shifted. Thought doesn't race through empty space like a beam. It arises here, inside your brain, in a web of neurons and chemistry. To you, it feels almost instantaneous. You can picture a galaxy on the other side of the universe, then the sun in your childhood sky, then the lamp beside your bed, all in one soft string of images. Nothing in physics is being broken, but your inner life reminds you that not everything meaningful is measured in meters per second. Then there are stranger connections, the kind that made even Einstein uneasy. Quantum entanglement begins when two particles interact or are created together in such a way that their properties are linked. Afterwards, you can separate them by a little distance or by light years. Measure something about one, and the other's corresponding property is found to be related perfectly every time. No signal has crossed the gap faster than light. There is no beam, no message racing between them. The link was written at the start, in how the pair was prepared. Still, it feels like a quiet defiance of distance. Change here, and there is an echo there, no matter how far away there is. You cannot use this to send a clear, controllable message faster than light, so the great limit holds. Yet entanglement whispers that space is not the whole story, that separate might be softer than it seems. Another small oddity, tunneling. Imagine a particle facing a barrier it doesn't have the energy to cross. In classical thinking, it should bounce back every time. But in the quantum world, the particle is also a wave of possibilities. A thin slice of that wave extends past the barrier. Sometimes, very rarely, this becomes reality, and the particle appears on the far side without ever having gone over in the usual sense. It has tunneled. No rule is broken. Nothing has gone faster than light. But the concept of a clear path with a clear speed starts to blur. In semiconductors, in radioactive decay, even in some processes inside your own cells, particles behave this way, slipping through forbidden regions in ways that feel more like changing the odds than marching along a road. So you lie there with the idea that the universe holds both hard limits and subtle exceptions. The speed of light still sets the boundary for how fast cores can move through space. Yet, not everything important is about racing from one place to another. Gravity reshapes space-time at light speed, but you feel its pull as a simple fact, always there. Darkness can fill a room in the instant a lamp is switched off, not because it travels, but because light has ceased. Intuition can jump ahead of reasoning, not by breaking physics, but by skipping steps your conscious mind hasn't traced yet. Perhaps the speed of light is not just a wall, but a threshold, a marker of what motion through space can do, and also a hint that some things don't travel in that way at all. Entanglement, imagination, emotional connection. They don't shuttle from here to there, they simply are, spanning gaps in ways that don't show up on a stopwatch. Your own awareness may be the closest you come to that realm. In a single moment, you can hold the memory of a childhood room and the image of a distant nebula. The distance between them dissolves inside you. Far and near become ideas instead of measurements. In that sense, you are already touching something that is faster than light, not as matter in motion, but as a mind not bound by geography. You rest in that thought, not rushing, not chasing, letting speed grow less important while presence becomes everything. From here, another vision begins to form with its own quiet gravity. You followed light across the cosmos and through your own body. Now you wonder what it was like before light had such freedom. Was there a time when photons existed but could not roam? When the universe glowed but could not be seen? You breathe and let your thoughts drift backward, further than any star's age, further than any galaxy's history, into the early youth of everything. You arrive at a time when the universe is only a few 100,000 years old. Compared to its current age, it's just learning to breathe. There are no galaxies yet, no stars, no planets. Space itself is smaller, denser, hotter. Matter and energy are packed together in a thick, glowing fog. In this young cosmos, light is everywhere but trapped. The universe is filled with a plasma, free protons, free electrons, and high-energy photons, all jostling in a dense crowd. Every photon that tries to move is almost immediately scattered by a charged particle. It is absorbed, re-emitted, deflected over and over, taking a zigzag path that never gets far before being interrupted again. You can imagine being inside this early fog. Everywhere you look is the same searing brightness. There is no clear line of sight, no distant object to focus on. Light and matter are locked together in a constant exchange. The universe glows intensely, but there is no transparency, no open space for light to glide across. It is like being inside a star, brilliant, but blind. As time passes, the universe expands. With that expansion, comes cooling. The particles lose some of their frantic energy. Protons and electrons, once racing independently, begin to slow enough to join together. They form the first neutral atoms, mostly simple hydrogen. This change is quiet but profound. Neutral atoms don't scatter light the way free charged particles do. As more and more electrons are captured into atoms, the fog thins. The photon, that used to be bounced around relentlessly, now has a chance to slip between obstacles. There comes a moment when the balance tips. Enough atoms have formed that a photon can travel a long way before encountering matter. Suddenly, the universe becomes transparent. Light, for the first time, is free to go in long, clean paths. It streams out in every direction, filling space. This turning point is called recombination, but you can think of it as the first time the cosmos opens its eyes. The trapped light is released. Space becomes clear. A flood of photons begins journeys that will last billions of years. Many of those original photons are still moving today. As the universe has expanded, their wavelengths have stretched and cooled. What began as fierce, bright radiation has become a gentle bath of microwave light, too soft and low energy for your eyes to see. Yet, it is all around you, passing through the room right now. We call this ancient glow the cosmic microwave background. It is like a baby picture of the universe, a frozen snapshot of that moment when light slipped loose and began to travel freely. Sensitive instruments can detect it in every direction, a nearly uniform whisper of radiation. Hidden within that smoothness are tiny ripples, slight differences in temperature and density, small variations in brightness. They seem almost trivial, but those little wrinkles are the seeds from which structure grew. Regions that were slightly denser pulled in more matter over time. Those became the first clumps, then the first stars, then galaxies and clusters. Everything large and intricate, the Milky Way, the Sun, Earth. You grew out of those subtle variations in the early light. So as you lie here, you are, in a sense, resting inside that ancient afterglow. Your atoms were once part of that hot, crowded plasma. They passed through phases of stars and gas and dust before becoming bones and blood and thoughts. The light released back then still threads through space, a background presence behind every night sky. You are not separate from that story. You are made of its pages. The universe expanded and cooled, and light found room to roam. From that roaming came the stars that forged your elements, the planets that gave you a home, the days and nights that set the rhythm of your life. When you think about that early fog and the moment it cleared, you're not just picturing a distant event. You're remembering, in a very quiet way, something your own matter has lived through. That ancient light is not just a distant echo. It is part of your background too, a soft, cosmic memory that has been shining, in one form or another, since long before there were eyes to see it. Maybe that's why, when you look up at the stars or rest your face in a patch of sunlight, there's a faint sense of recognition, as if some quiet part of you is thinking, oh, I've known this forever. You're not just a body drifting through space. You're a chapter in a story that light started long before you were born. That ancient glow you drifted through the soft remnant of the universe's first light is still here with you. It has cooled and stretched as space has expanded, its color sliding down into microwaves, its energy thinning out. Our instruments can still hear it now, that faint background hum from the beginning, but it won't always be so. As the cosmos keeps expanding, that early light will be stretched beyond what any future telescope could detect. There may come a time when distant observers, if they exist, look into their sky and see no trace of that first glow. They might never know how their universe began. You do. You floated in that fog. You felt the moment when photons slipped free, seen in your mind the soft, uniform light of a newborn cosmos. You carry that understanding in you now, like an old photograph you can't quite forget. From that memory, another curiosity rises. Light was once trapped in a dense mist, and now races freely through the vacuum of space at its full cosmic speed. But when it meets other things, water, glass, air, your own eyes, something changes. It slows, it bends, it splits into colors. How can something so swift be delayed at all? You let your thoughts follow a single beam of light. In empty space, it travels as fast as anything can, about 300,000 kilometers every second, smooth and unhindered. Then it reaches something denser, a raindrop, a crystal, a window pane. The moment it enters, its story shifts. It's still massless, still trying to move forward at its relentless pace, but now it must interact with the atoms it passes. Inside matter, light is caught and released again and again by the electrons in each atom. Each interaction is incredibly brief, almost unimaginably so, but added up over many atoms and many little pauses, they become a noticeable delay. To you, looking from outside, it seems as though the light is moving more slowly through that substance. In water, it moves at only about 3/4 of its vacuum speed. In glass, slower still. Not because its nature has changed, but because it keeps stopping to have tiny conversations with the material it crosses. You picture yourself underwater, the surface rippling above, shafts of sunlight slanting down. Those beams reaching you there are not the same straight paths they would follow in empty space. They have been bent and softened. This bending is refraction. When light enters a new medium, the part of the wavefront that arrives first slows first, and the rest follows, causing the entire path to curve. It's like walking from smooth floor onto deep sand. The foot that hits the sand first slows, and your body turns. Light does this constantly. That gentle curve is how lenses bring images to a focus. It's how eyeglasses sharpen blurry vision. It's how the world gets painted onto the back of your eyes. You follow a photon as it enters a tiny raindrop hanging in the air. It bends as it goes in, reflects off the inner surface, then bends again as it leaves. Along the way, something lovely happens. Not all wavelengths of light respond to glass or water in exactly the same way. Red, with its longer waves, bends a little less. Violet, with its shorter waves, bends a little more. What entered as a single, mixed beam emerges spread apart, its colors unbraided into a spectrum. A rainbow is just sunlight slowed and sorted by countless droplets, color laid next to color by tiny differences in delay. Every lens you've ever looked through, every polished stone that sparkled, every shimmering edge of a diamond owes its beauty to this simple slowing and bending. Even inside you, light is gently delayed. Photons pass through your cornea, your eye's fluids, your lens, the clear gel that fills the eye. Each layer nudges and guides them, slowing and steering their path toward the retina. Transparency doesn't mean emptiness. It means cooperation, matter, allowing light through, but on a slightly altered schedule. You are shaped by light's slowness as much as by its speed. That thought brings another, more subtle question. If light can be slowed by matter, could something else race past it? You already know that in a vacuum, nothing can outrun light. But inside a medium where light is delayed by all those tiny stops, other things can, in a sense, get ahead. Imagine a charged particle, like an electron, shot through water at very high speed. It can't exceed light speed in empty space, but it can move faster than light's reduced pace inside the water. When that happens, the particle leaves behind a distinctive glow, a soft, ghostly blue halo. This effect is called Cherenkov radiation. It's a visible shockwave, a light version of the sonic boom created when a plane outruns sound in air. In deep pools of water surrounding nuclear reactors, you can see this eerie blue glow. It is speed made visible, not because the laws are broken, but because there are layers to what those laws allow. Light in vacuum still holds the ultimate limit. Light in matter agrees to move more slowly, and other particles briefly slip ahead of that slower pace, leaving luminous footprints behind. From all these stories, you start to feel that speed is not a simple, single thing. The speed of light in empty space remains a constant, a guiding rhythm. But inside materials, it becomes a partnership between photons and the atoms they meet. That partnership gives you lenses, prisms, microscopes, the focusing power of telescopes, the clarity of your own sight. Slowness, here, is not a failure. It is what allows light to create detail. As your thoughts soften around that idea, they curve naturally towards something more elusive, time itself. If light's motion helps us measure distances and build clocks, if its path tells us which events can influence which others, then what does it say about the direction of time? Why does everything you experience feel as though it moves from before to after, never the other way around? You notice time in small ways, the cooling of a mug of tea, the dimming of the sky, the rhythm of your breathing. Always forward, never back. Yet many of the fundamental equations physicists use look just as valid when run in reverse. A planet's orbit, an electron's motion on paper, they could go either way. Your life does not feel that way. You never see a shattered glass leap up and reassemble itself on the table. Rain does not rise back into clouds in neat droplets. A burned-out candle does not pull wax back into a fresh, untouched shape. These images feel wrong, not because they are forbidden by the basic mechanics, but because they are crushed under a different rule: entropy. Entropy is a way of describing how spread out and mixed up things are. Left alone, order tends to dissolve into disorder. Heat diffuses, tidy arrangements scatter, sharp distinctions blur. A tidy room has only a few ways to be just so. A messy room has many ways to be messy. Over time, systems drift toward the more likely, more disordered states. That tendency gives time its arrow. You recognize before as the moment when things were more arranged, and after as the moment when they have become more scattered. Light fits into this story, too. A photon emitted by a flame rushes outward, and rarely, if ever, returns to that exact source. Light from a star radiates into space, carrying energy away, thinning as it goes. Once that energy is spread out, it doesn't regroup by itself into the neat, hot glow it once was. It keeps moving outward, contributing to the general drift toward more evenly shared energy, toward higher entropy. In a way, light is always leaving. It streams off surfaces, out of stars, through windows, across rooms. It bounces from faces into film or sensors or memory. It doesn't run backward. It doesn't untravel. That one-way flight helps carve the difference between past and future. You can look at an old photograph and know that light once reflected from a person's face hit the film and left its trace. You can look through a telescope and see a galaxy as it was long ago, its light only just now arriving. Those photons are tiny messengers saying, "This happened." They never say, This will happen. The past leaves marks. The future does not. Shadows play along the same line. The shape of a tree's shadow on the ground tells you where the sun was, how high, from which side. As the sun moves, the shadow stretches and shifts. Each moment leaves a slightly different pattern. If you filmed the shadow and watched the clip in reverse, you would feel that something was off. The way the light and dark move tells you which way is forward. Physicists draw something called light cones to map which events can affect which others. From where you are right now, light can only reach certain places in the future. Other regions are forever out of reach. The past is the set of points whose light has already arrived. You sit always at the tip, able to see backward, but never ahead. You feel that more simply as memory. You remember yesterday because light and matter left traces in your brain, in your surroundings, in the world. Tomorrow is blank because no such traces exist yet. You can imagine, but you cannot recall. So perhaps the sense of time flowing is, at least in part, your awareness of light and energy constantly moving outward, of patterns dissolving and being rewritten. Warmth leaves your skin into the room. The glow of day seeps away into night. Photons slip off into space and don't come back. Entropy grows, and you ride that increase like a leaf on a slow river. You don't need to grasp every equation behind it. It's enough to feel the direction. A whisper from the past, a warmth fading from your cheek, a ray of light sliding along the wall as the sun sets. In those small shifts, time's arrow and light's journey are quietly the same story, and you are resting in the middle of it, held by both. You close your eyes and notice that this quiet moment is full of little messengers from before, light from distant stars, light bouncing off your walls, light reflected from your own hands. All of it arriving now, all of it softly saying, this happened, this was, this is. You rest in that. The arrow of time stops feeling like a knife that cuts the past away, and more like a beam that shines ahead, not sharp, not harsh, just steady. One direction, one gentle glow, always forward. At the edge of that comfort, another curiosity appears. If time can stretch and slow, if gravity can bend the path of light and even delay clocks, what happens in the most extreme places of all? What happens where space curves so deeply that time itself seems to lean inward? Your thoughts drift toward one of light's strangest boundaries, a black hole. Light has always been your companion, a guide out of darkness. It has felt like the thread that ties before to after. Now you imagine floating near an object where even that thread thins and disappears. There's no panic here, only wonder. A black hole is not a monster hiding in space. It's a place where matter has been squeezed into an incredibly small region, so dense that gravity doesn't just pull, it reshapes the stage itself. Space dips, time stretches, everything bends toward a quiet center. Around that center is a boundary called the event horizon. It isn't a hard surface. There is no glowing ring or solid shell. It's simply the place where every possible path leads inward. Cross it, and there is no way back out, not even for light. You picture the horizon not as a cliff, but as an invisible shoreline in space-time. From far away, a photon falling toward it appears to slow. Its color shifts to red, its energy stretches thinner and thinner, as if time itself were pulling at it. To a distant observer, it seems to freeze just above the edge, fading into nothing. But along the photon's own path, there is no pause. It moves forward, as always, crossing the horizon and continuing inward. Both views are true. each from its own frame, closer in time, behaves even more strangely. A clock dropped toward the horizon would appear to tick slower and slower until, from far away, it almost stops. The deeper you fall, the more time stretches for you compared to someone far out in calmer space. Light, which usually travels in straight lines, begins to spiral inward, following the curves of space-time itself. Just outside the horizon, there is a special region called the photon sphere, where light can orbit the black hole in circles. You imagine a ring of photons chasing their own tails, looping endlessly around a darkness they can never quite escape and never fully surrender to. Farther in, all paths point inward. Not even information can climb out. This is the deepest quiet the universe knows. And yet, black holes are not completely black. Through careful thought, Stephen Hawking showed that at the edge of the event horizon, quantum effects cause tiny pairs of particles to flicker into existence. One falls in, the other escapes. From far away, it looks as if the black hole is slowly giving off a faint glow. Hawking radiation losing mass bit by bit over an enormous span of time. Even the darkest place, it seems, has a kind of light, a way of letting go. You think about that, a boundary where light disappears, but still leaves a mark. Black holes curve the paths of passing stars. They bend starlight into arcs and rings. They make nearby gas swirl and blaze. When two of them collide and merge, their motion sends ripples through space-time itself. Gravitational waves that instruments on Earth can feel as tiny shivers. You may never see inside a black hole, but you see its influence everywhere around it. Light, in that sense, still tells the story, even from the edge of silence. From here, your attention turns to something even harder to see. Not just the places where light ends, but the things that never shine at all. The more you learn, the more you discover that most of the universe does not speak in photons. All the stars you've admired, all the glowing nebulae, all the gas and dust and planets and people, the familiar, luminous stuff add up to only a small fraction of what exists. The rest is dark, not just dim, but invisible. You float in that thought and begin with dark matter. When astronomers measure how fast stars orbit in galaxies, they find a puzzle. The outer stars whirl around so quickly that, if only visible matter were present, they should fly off into space. But they don't. Something unseen is holding them in place. You imagine this dark matter as a silent framework, cradling each galaxy. It doesn't glow. It doesn't reflect. It rarely, if ever, bumps into ordinary atoms, but it has gravity. It pulls. It shapes. It's like a hidden skeleton of mass that keeps the bright parts from falling apart. We can't see dark matter directly, but we see its fingerprints in how galaxies spin, in how clusters of galaxies move, in how light bends as it passes large regions of space. We see its influence frozen into the tiny ripples of the cosmic microwave background. From these clues, scientists estimate that most of the matter in the universe belongs to this invisible kind. Dark matter streams through you right now, through Earth, through everything, without a sound. Beyond that, there is something stranger still: dark energy. If dark matter pulls things together, dark energy seems to push the universe apart. When astronomers looked carefully at distant exploding stars to measure how fast the cosmos was expanding, they found that the expansion isn't slowing down under gravity. It's speeding up. Space itself is stretching faster over time. To describe this, we use the name dark energy, not because it's gloomy, but because it is unknown. It doesn't shine. It doesn't clump. It appears as a property of space itself, gently urging galaxies away from one another. Add the numbers up, and a simple picture emerges. Only a small slice of the universe is made from the atoms you know. A bigger slice is dark matter, invisible mass that holds things together. An even larger slice is dark energy, the quiet pressure driving things apart. You begin to see the cosmos differently. The stars are not the whole story. They are the bright punctuation on top of a much larger hidden structure. Dark matter and dark energy are like the grammar behind a sentence, unseen, but shaping how everything reads. This might feel oddly familiar. Your own life has a bright surface, the things people can see and touch, and a deep interior full of emotions, memories, and ideas no one else can directly observe. The unseen parts are not less real. They guide everything. So it is with the universe. The visible galaxies are only the glowing tips of something vast and mostly silent. From here, your thoughts drift forward. Following the long arc of time, you have watched light blossom out of the early universe. Light weave galaxies together. Light bend around black holes and scatter through you. Now you wonder how this story continues when ages beyond ages have passed. For now, stars still burn. They fuse hydrogen into helium, then heavier elements shining as they do. But even stars have fuel tanks. The most massive ones live fast and die spectacularly, in bright explosions that scatter new elements into space. The smallest red stars sip their fuel and can glow for trillions of years. Still, one day, even the thriftiest star runs out. Very slowly, the age of starlight comes to an end. Fewer new stars are born. Old ones cool into dim embers, white dwarfs, then darker remnants. Galaxies grow quieter. Black holes and cold cinders remain. Over unimaginably long stretches, even black holes radiate away their mass through Hawking radiation. They shrink and eventually vanish. What's left is a universe filled with very thin, very cold particles and faint, stretched out photons. Expansion continues. Everything becomes more spread out, more uniform. This distant stage is sometimes called heat death, though it's more like a deep cool. Not an ending of fire, but the fading of contrasts. No hot and cold, no dense and empty. No gradients left to drive new change. Everything is as mixed as it can be. When nothing much happens anywhere, the idea of time itself begins to blur. Time is tied to change, to events, to differences between one moment and the next. In a universe where almost nothing changes, what does it mean to say that another second has passed? You float inside that thought without trying to solve it. It's enough to feel the scale, from the first trapped light in a young, hot cosmos, to a future where even black holes have exhaled their last bit of energy. This is not a story of failure. It's a story of completion, of what light becomes after trying every possible path, of what the universe becomes after using every contrast, every difference, every spark. And where are you in all of this? Right here, in a brief, bright interval, where stars exist, where planets are warm, where life can ask questions about its own origin. You are a pattern made of atoms forged in stars, lit and guided by photons, carried forward by time's quiet arrow. You are, in a small and lovely way, something light has done with itself. As sleep draws closer, let that be enough. Let your breath move as gently as starlight crossing space. When you wake, you can carry a little of this wonder with you, letting it soften your attention, slow your rush, widen your gaze when you step outside and feel sunlight on your skin, or see a single star in a dark sky. The universe is speaking through light all the time, and you, simply by being here, are listening. If this long, quiet journey has brought you calm or sparked a sense of gentle curiosity, you're welcome to share it, to leave a small light on for someone else who might need it. And if you'd like to return to more stories told in this slow, sleepy language of science, a simple like or subscribe helps keep this little corner of wonder glowing. For now, let your thoughts dim, let your body rest, and drift into the dark with the easy knowing that you are, and always have been, made of stars.